Okay, hello everyone. This is Maria Aglope from Mesky Ghost Associates, and I would like to welcome all of you to our today's webinar on Chapter 10, Means of Egress. Our speaker today is Mr. Kevin Scott. While he's presenting, please type in your questions at any time in the chat box at the bottom of the Zoom screen, and the questions will be addressed by Kevin at the end of the presentation. The chat box will serve as our Q&A box, and only Kevin and I will see the questions submitted in there. Also, you should have received the PDF handout of the webinar material Kevin is going to show during his presentation. Having a printed copy of that will facilitate your notes taking during the webinar. With that, Mr. Kevin Scott, ladies and gentlemen.
Thank you, Maria, and good morning, everyone. Welcome back. Today we're talking about Chapter 10, Means of Egress. And we're going to start with just what is the basics of the means of egress. And let me start with this basic. My opinion is that the means of egress is one of the most important aspects of building construction. I am a fire person. I was a firefighter. I was a fire marshal. I was a deputy fire chief. But I will tell you that the standard acceptable fire is when everyone gets out safe and the building burns down. Hey, everyone got out safe. How'd they get out safe? They had adequate egress and they were able to follow the egress path to get outside the building. Now, as a firefighter, I'm also going to tell you it's a better fire if we don't lose the building and we only lose a room or a portion of the building. But that building burned down and no other damage didn't spread anywhere else, that's our acceptable level. That's it. But everyone gets out safe is the whole goal of Chapter 10. And to accomplish that, we look at some fundamental design concepts. How many occupants are in the building? And the number of occupants will determine the number of exits required, the width of the required exits, what is the location of those exits? How far do I have to travel? What's the distance I have to go? Do I need fire resistance rated construction for components in my exit path? In other words, to protect that exit path during my egress. What are the design of those components, whether it be a stairway or a corridor or an exit door? What's the design of those components? And on that exit door, what kind of hardware do I need? Do I need lighting and exit signs? Emergency lighting and exit signs. All of these are items we're going to discuss here. Chapter 10 is a big chapter. There's a lot of information there. We'll get through this. First concept you need to understand with regard to application of code requirements. There are three parts of the means of egress. It's either an exit or an exit access or an exit discharge. So my entire path from anywhere in the building to the public way, because that's where our exit path terminates, is one of those three components. One of those three components. So we need to understand what those are. We'll start with an exit. The definition is very clear, very clear. It says it's the portion of the egress system between the exit access and the exit discharge. Oh, great. But it also says it's one of these 7 items. It is an exterior exit door, that door that leads out of the building. It's an interior exit stairway. And we'll learn that the interior exit stairway, by that term, is in a fire-rated vertical enclosure. It has fire rating that comes with it. Be careful when you're reading the code because there are also interior exit access stairways. They are different. There is no fire-rated enclosure. The requirements for them are different. The requirements for the stairs and the handrails and the guards and all that is the same. But it is not considered an exit unless it's in a fire-rated enclosure. Interior exit ramps. That's a ramp inside the building that is in a fire-rated enclosure. And an exit passageway. An exit passageway looks like a corridor, but has a much higher level of protection. In this drawing here, the level of protection in that exit passageway would be equivalent to the requirement for the stair. We'll talk about exit passageways. Exterior exit stairway. The stairway is outside the building. Exterior exit stairway. I've left the building. Exterior exit ramps. I've left the building. I'm on a ramp. And a horizontal exit, which is a component of the building, which essentially divides the building into areas that are considered to be an area of safe refuge on one side or the other. I can go through that to a level of protection, and I can delay my response or slow my response. I have more time to get out of the building. When the code says an exit, it means one of those 7 items. Notice that the interior corridor is not considered an exit. This is critical because when we measure our exit access travel distance, we are measuring to an exit. To an exit. Okay, so those are our exits. Our exit access is from anywhere in the building to an exit. The exit access distance is the travel distance we measure to determine how far away is that exit. Once we get through the exit, we are then in the exit discharge. The discharge is between the exit and a public way. And a public way. Not just the parking lot. Parking lot is not a public way. The public way, the deeded land for the public use to the street. There is one or alley. There is one option to this where I go from my exit to an area of safe refuge. I'm outside the building, at least 50 feet away from the building. This is a concept that is used, well, we've used it for decades at schools. When you have a fire drill at a school, the students do not go to the street. They go to an area of safe refuge. We can use that same concept in any building. Everyone's left the building and they are at a safe location. Now, in this example here, some exits go to the area of safe refuge, some exits go to the public way. It can be mixed. It can be mixed like that. So when we're looking at our exits, we have to understand what the occupant load is, because the occupant load will determine how many exits we need, how far apart the exits have to be, how do we protect those exits, the door swing, the type of hardware, the many requirements in the code for sprinklers or fire alarms based on occupant load. So we have to understand how we determine the occupant load. 2 ways. Either I have fixed seating or I do not have fixed seating. Fixed seating, it means that the seating does not move. It is attached to the floor. Fixed seating, the seating is attached. And so when we have fixed seating, it's simple. Count the seats. How many people can we put in there? And when we have benches or pews or just bench type seating, we look at 24 inches per person in a dining setting, 18 inches per person everywhere else. 18 inches per person, and I'm going to tell you right now, I don't fit in 18 inches. But myself and my granddaughter, between us, 18 inches average, we can do that. So this number, 18 inches, is just an average that's used to determine the occupant load. Because we're going to use the occupant load to design the exiting system. I don't have fixed seating. I don't have fixed seating. Then I go to table 1004.5, and we're going to use that based on the design and what I'm doing in the building. So my occupant load factor, this is the number I'm going to use, and essentially it says that for or storage areas, I get 300 square feet. That's my factor. Basically saying in 300 square feet, we're going to assume there's a person. And it changes based on the function of the space. Key understanding with this table, it does not say occupancy classification. It says, what's the function? What's the function? For example, I have educational listed here. It doesn't say Group E. It doesn't say Group B intentionally, because my educational classroom area, 20 square feet per person, my 20 would be applicable in the elementary school, the high school, both classified as Group E. It would be applicable in the college, university, classified as either a Group A, if the occupant load is 50 or more, or Group B, if it's less than 50. So this table is based on the function. The function. Keep that in mind, because it don't get misled by the titles there and think they're referring to occupancy classification, because, and this is just a portion of the table, because many of them say educational, oh, Group B, institutional, oh, Group I. Oh, wait, my Group B ambulatory care facility will fall into there too. So look at the function when we're looking at this. And how do we apply this? For assembly, I have, for gaming floors, 11 square feet gross. Exhibit halls, 30 square feet net. What the heck is that gross and net stuff? You need to understand what it is, and then we'll talk about how you use that in plan review. Gross. Gross means every area that has a floor, essentially, is what it means. I exclude elevator shafts, ventilation shafts. There is no floor. So I can exclude those areas. That's my floor area when it says gross. Other option, net. I get to still exclude those areas with no floor, and now I exclude essentially not normally occupied spaces. The corridor, bathrooms, mechanical rooms, equipment rooms, I can exclude those. Now let's talk about how do I apply this during plan review. Because when I go back here and I say, okay, it says for an assembly, let's take an assembly. We're going to have a dining area, which is unconcentrated tables and chairs, 15 square feet per person. So if I take just the net area and divide it, I come up with, I'm going to just make a number, 100. If I take the entire floor area and don't worry about either the gross or net concept, I'm going to come up with a higher occupant load. And if that higher occupant load has adequate exiting, I come up with 120. I have 2 exits. I've met the requirement for 120. I'm done. I've complied. I did not have to go through and calculate what's the size of the restroom, the corridors of ventilation. I didn't have to go through that math. Take the entire floor area, ignore gross or net. If the building complies based on that, it will comply based on gross or net, because you're being more conservative based on the exiting provisions. Now it comes in closer, it doesn't make it. Okay, you might have to go back and look at, well, what's the gross or net? What's the gross or net to do that? But most times it will apply. The only time it makes a significant difference is when I'm at a threshold of code requirements. Is it 50 or more? Is it 49 or 50? 99 or 100? 299, 300, 500, 501. Where code requirements change, it makes a difference. And you might have to get more specific. But other than that, go through, just ignore the gross or net. If it works, you're done. Move on to the next item. So here's how that table works. I have a business office center. We go back to our table, and we have a business. Doesn't say group B, but we have a business area. And under this, we have business areas, 150 square foot, concentrated uses, says see section 104 or 1004.8. What that section says is I can have more people than this will allow. And it's specific for computer rooms, data entry areas, call centers, stock exchange kind of rooms where you just got a lot of people. You can increase that occupant load, but we'll look at 150 because that's just a typical business. You take the square footage of the building, 10,800, use your occupant load factor of 150, divide. Occupant load 72. Then I use that 72 to determine how many exits. Do I need panic hardware? What about spacing of the exits? How many inches of exit width do I need? Simple as that. Just take the occupancy, look at the occupant load factor, and evaluate it based on that. We subtracted out, let's see, business, it says gross. So we subtracted out ventilation shafts. When we subtract out ventilation shafts, this number is just going to go down. So you've looked at the worst case situation. What's the occupant load they could have in there? If the exiting complies, we're good. But I do have some areas that have multiple functions in a building. A recreation center. Well, is it dancing? Is it dining? Is it a public meeting? What are they doing in there? So you will have times when the function is different. So we go back to assembly. People are gathering together. It's not, it may or may not be a group A, but people are gathering together. And I have three options: concentrated at 7 square feet, standing space at 5 square feet, and unconcentrated, which is tables and chairs, 15 square feet. It says chairs only, not fixed, for concentrated. Because if it's fixed seating, I count the seats. So I have 7, 5, and 15. Oops, so I go, that blew that. Hold on. Okay, so we're back to our recreation center. Okay, so I have multiple uses. So I may have, or I should have, an occupant load sign that says, if you're doing this, you've got table and chairs, here's your occupant load, 490. If it's chairs only, geez, that over doubled. Standing room only, it's a dance. So these are the potential occupant loads I could have for uses in this building. If I take this one, standing room only, and design my exiting system to handle that occupant load, we've already covered these. We don't have to worry about it. We've already made it. If I can handle that, I can handle less than that. Now, there's times when our occupant load, we need to add it together in different rooms. Typically, when we're doing egress evaluation, we have to look at each room, make sure it complies, then the floor, then the building. We have to look at each space. So we look at this. Here's my floor here. I've got 4 areas. Occupant load of 5 in this room, 10 here, and 10 here. At 10 occupants, 1 exit required, the door can swing in, we're good. But now this area, which has 30 occupants, how do we design that one? When we have areas that travel through another room, we have to add them together. We have to add the occupant load together. Could be a different occupant load factor used in this room than in this room. This is my storage room. This is my office space. This is my conference room. We could have a different occupant load factor used in each space. So what's the number of occupants that are leaving and going through this room? When we get to this room here, we have to add them together. When we look at the exiting out of this room here, we have to add all of the occupants using that room, add them together. And so we started with 30, now plus 10, plus 10, plus 5, we have 55. This example is a perfect example because at 30, I only need 1 exit. At 30, my doors can swing in. I've now crossed 50. 50 or more, I have to have 2 exits. When 2 exits are required, I have to have exit signs. When at 50 or more, the doors have to swing in the direction of egress. So many changes occur when I cross that threshold. So make sure we add them together. The mezzanine, I've got a mezzanine in the building. I look at the mezzanine itself, evaluate the occupant load and the egress from the mezzanine. Then I have to look at the occupant load for the floor below. But I add them together because the mezzanine is exiting through the floor below. I add them together. When I get down to that main floor, the exiting requirements are based on that combined occupant load. I've got a restaurant with an outdoor eating area. 2 options for the designer on my outdoor eating area. Can I exit this way, or do we design it so they all exit back through the building? So we have to look at this area. Even though it's outside the building, we look at this area. How many exits? What's the occupant load? How many exits do we need? They only need 1 exit, comes back through the building. But when they come back through the building, we have to add this occupant load to this occupant load to design the egress system out of the main area. So when we're looking at the capacity in the code, the capacity is how many inches, how many people can a doorway handle? How many people can the stair handle? How many people can the corridor handle? We're looking at the capacity in the means of egress. And we're going to look at that width, how many inches. We're looking at that width based on the occupant load. But there's also some minimums we have to comply with, but we look at first at the occupant load. So for group H, 1, 2, 3, and 4 occupancies, I take the occupant load I just calculated, multiply it times 0.7, and that will tell me how many inches of exit width I need. Total, not for each exit, but total. For other than those occupancies, I multiply it times 0.3. And I can take that 0.3 and change it to 0.2. In other words, I can make my exits narrower. If the building is sprinklered and the building has an emergency voice alarm communication system, which is our fire alarm system with voice directions. This requirement applies whether it's NFPA 13 or 13R system. So other than stairways, everything else, my corridors, my doors, my ramps, my exit passageway, everything else, we have a different factor. My occupant load and my H occupancies goes from 0.7 to 0.4. And the reason that this changes when we're walking on a flat level surface and we get 0.4 inches per person, then we get to a set of stairs, we slow down. So we widen out the stairway to accommodate that change in speed. We widen out the stairway, we get back down to a flat level surface, we go back to the 0.2. So from when it's not a stairway, we use 0.2 inches per person. The same allowance applies that if the building is sprinklered and has emergency voice alarm communication system, I can reduce that to 0.15. I can reduce that to 0.15. So here's an example of how this would apply. Because here's my exit, one exit out of a building. This portion of the exit, okay, and we'll say this floor has a total of 400 occupants. And when they come out into the corridor, they can go either direction. So we're going to split that 200 this way, 200 that way. So here is at the end of the corridor, my exit from the building. So I've got 200 occupants in that building. So my corridor width would be 200 times 0.2. Building's not sprinklered, times 0.2. So my corridor width is 40 inches. However, there's another requirement that says when it serves 50 or more people, it has to be a minimum of 44. So it can't be 40. It's got to be 44. I have to comply with both requirements. This is one of the reasons why when you add, when you ignore the net or gross, it's going to come out, you're probably going to comply because there are minimums that apply to the corridor and also to the exit doors. In this case, my 200 occupants times 0.2 inches per person gives me 40 inches. The minimum width for exit doors or exit access doors is 32 inches of clear width. So my door width can be 40 inches. And I can have a 40-inch door. It's not the typical door, but I can have a 40-inch door. But in between there, I've got a set of stairs. When I'm on the stairs, I have a different factor, 0.3 inches per person. And I come up with 60 inches. So on this exit, I've got a corridor width. I've got 44 inches here, 40 inches in the door, 60 inches in the stairway, 60 inches in the landing, because the landing has to be as wide as the stair. But when I get back down to this exit door, I'm at 40 inches because now we're back on a flat surface or a level surface and we're moving at the 0.2 inches per person. Minimum egress width. When I determine what my minimum egress width is for the building, and I've got my exits, it says when multiple means of egress are required. That means I've got more than one exit. They have to be sized so that if one path is blocked, I can't use it. That's where the fire is, that's for building collapse, whatever the hazard or the problem is, that exit path is not available at this time. If one of the exits is blocked, one exit blocked, I still have at least 50% with the other exits. So here's my building. I've got an occupant load of 600 in the building. When I cross 500 occupants, I need 3 exits. So I've got 3 exits. This 1, 2, 3. This is one exit. It has 2 doors in it, but it's one exit. It may have 4 doors in it. And then the question is, how far apart are they? We'll talk about that in a minute. But I've got 3 exits there. At 600 times 2, I need 120 inches. I've got it. 32, 32, 64, 128. I've provided that. But now we have to look at it and say if one exit's blocked, and as a plan reviewer, you can say that's the exit. The reality is they have to evaluate every exit. The only one that makes a difference is the largest exit. So if that one's blocked, do I still have 50% available? I've got 64 inches. I needed 60, 50% of the 120. It works. That works great. Let's look at this building. Occupant load of 400. I'm below 500. 2 exits required. And there are many buildings designed like this. Here's my main entrance, set of double doors. Here's my stock entrance, exit, whatever it may be, out the other end. 2 exits required below 500. 400 times 0.2, 80 inches of egress width. I've got 96. I'm doing good. Except when that exit is blocked, I no longer have 50%. 50% would be 40. Okay, I've got 32. I've got another way out, yes, but it's not wide enough. Options from the designer. Wider door, an additional door. Design option. The code does not tell you how to fix it. It just tells you this design doesn't work. There's many options, but it's not permitted when that remaining exit width is less than half. So when do I know how many exits I have to have? Based on the occupancy classification. Yeah. This says occupancy. The occupancy is the classification. The occupancy is not the occupant load. Words are defined. The definitions are very critical, and especially in egress, a lot of words or terms are similar. We already talked about the interior exit access stairway versus the interior exit stairway. Almost identical term, 2 totally different things. This is occupancy, not, and this one is occupant load. Don't get confused with those. Read the code carefully. And typically, our typical response when I need 2 exits is, oh, you need 2 exits at 50. Because when I hit 50, this is the table that says, if I comply with this table, I only need 1 exit. Out of any space, any room, I only need 1 exit. The typical number we use is 50. And that's appropriate for A, E, M, B, and F occupancies, because when I exceed 49, I need 2 exits. Be aware, though, that it's not the only number that applies. We've got 10. When I exceed 10, I need 2 exits. The one oddball here is a group S occupancy warehouse. When I have 30 or more occupants, I need 2 exits. So to have just 1 exit, I have to comply with the maximum occupant load and the maximum common path of egress travel. Common path of egress travel means how far do we all go, how far do we all travel before we have a choice of 2 directions, before we can choose, I'm going to go that way or I'm going to go that way. But in a room with only 1 exit, everyone has to go through that door. That's our common path of travel. If I get into a corridor with exits at each end, as soon as I enter that corridor, I've got a choice. So this says, what's that common path of travel? And then also, is the building sprinklered? And if it's sprinklered, I'm sorry, if it's not sprinklered, is the occupant load above or below 30? And that determines, okay, if it's a M occupancy, occupant load of 40. So I'm above the 30, but wait, but it's sprinklered. I get 75 feet of travel distance. I can have a common path of travel of 75 feet. At that point, I either have to be out of the building or have a choice of two directions to go. If I don't comply with that requirement, I have to redesign the exit system, add another exit, reconfigure the building, whatever it takes. But there's my typical system, 75 feet. If it's less than 30 not sprinkled, it's still 75 feet because of these higher hazard facilities. So footnote A says it's sprinkled with either NFPA 13 or 13R for residential, whichever one is appropriate for the building. So here's an example. First rule, every space has to have at least one exit. That's the door I came in to access the space. Now I have to know, do I need two exits? If I exceed the occupant load in the building, well, we've got to figure what's the occupant load here. So we use our table. That building is retail. Doesn't say retail on here, but it does say mercantile. 60 square feet gross. We're going to ignore the gross. And we have 2,600 square feet divided by 60. I get 43.3 occupants. 43.3. Question, which way do I round? I can't have 0.3 people in there. So would I round it down or round it up? That is a policy decision for your jurisdiction. But whichever you choose, always round the same way. Me, if I can get a third of a person in there, they're going to put the whole person in. I'm going to round up every time. 43.1, that's 44. And the only time it makes a difference again is at one of those thresholds. So I've got my building. I've got an occupant load of 44. I look at my table. It's retail. I've got retail group M. I'm below 49. Okay, I'm good. I have one exit. I'm done. I've only got one exit. But now I have to look at the common path of egress travel, which says for my group M, I've had 44. So I do not qualify here. So I've got to, wait, was the building sprinkled? No, it's not sprinkled. So I've got 75 feet of travel, 75 feet of travel. So I measure my travel distance. It's 80 feet. And we'll talk about measuring travel distance in a minute, but that's how you measure travel distance. 85 feet. Okay, now what? Now what? I've exceeded the common path of travel. Now what? Now what is the designer redesigns? Add a second exit. Move the exit door. Now I've just moved the exit door. Did not change the configuration of the building. Now I measure from that same location and I'm below 75 feet. So the solution, how I fix it, is up to the designer. It's up to the designer, but there are many ways to resolve the problem. My common path of egress travel, we need to understand that. Here's our definition. Common path of travel is the portion of the exit access travel distance. So we're in the exit access. Measured from the most remote point within a story or a room to the point where they have separate access to two exits or exit access doorways. To the point where they have separate exits. That's the key. So here's an example. Common path of travel. I've got 2 rooms here with a single door. Is that okay? So I'm looking at my common path of egress travel. And let me tell you right now, that is not the way to measure. Because when I get to this point in the corridor, yes, I'm in the corridor, but I still have to travel this way. I haven't reached the point where I have 2 choices yet. So I'm going to measure that distance. At that point, I have a choice. Continue straight ahead, turn to the right. That's my common path of egress travel that is limited. We will also have another measurement, again, starting here, here, all the way to an exit. That's our exit access travel distance. This is our common path of travel. Anytime I have one exit, it applies. As soon as I have 2 exits in a room, common path of travel no longer applies, because from anywhere in a room, I've got 2 choices. Doesn't matter. Doesn't matter. I've got, so as soon as I have 2 exits, this issue is resolved. Here's a floor plan. I've got some clerical offices in a sprinklered building. My occupant load, I've figured the occupant load, I've got 14.7. You know what, but that's really 15. So then the question is, I'm below the 49. Is that the measurement for my common path of egress travel? I reach a corridor. I can go either left or right in the corridor. Oh, I've got a choice. Yes, you do. But you all come back to this point here. Everyone has to travel through that point to get to this corridor. So our common path of travel, where I have 2 separate exits available. This design, even though I have a choice around this corridor here, this is really no different than I'm in a room and there's a desk in the middle of the room. Am I going to go right around the desk? Am I going to go left around the desk? Once I pass that desk, we're all still going the same way. So I have to measure it to the point where I actually have 2 choices. That is my measurement for common path of travel. Does it comply? Oh, wait, we had group B. Group B, I'm below the 49. I had 15. Building was sprinklered. I get 100 feet. Huh. Okay. So does it comply? Yeah. 95 feet. And at 100, what if it's 100 feet? It still complies. It still complies. So it's over 100 that it doesn't comply. So can that area have only one exit? Based on common path of egress travel, yes, on that section. However, another section of the code talks about dead-end corridors. And when we look at dead-end corridors, if I'm traveling down this wall, the corridor's smoky, the lights are off, I've just got exit signs, I'm feeling the wall as I travel down there, and I make this turn, I've got to come all the way back to this point here. I made the wrong turn. This is a dead-end corridor. This is a dead-end corridor. We will talk about that shortly. Minimum number of exits. Okay, if I'm below that table, 1006.2.1, I can have 1 exit. I don't qualify in that table, I've got 2. When do I need 3? When I exceed 500, one of those thresholds we talked about it. 501, I need 3 exits. When I'm over 1,000, I need 4 exits. There are times when I can have 1 exit from an entire story in a building, different table. The other table we were looking at was based on rooms or spaces. This table now is looking at the entire floor, the story, or the building, if it's only a one-story building. For a one-story building, I've got all the same occupancies, and I've got all the same numbers here that we just looked at for egress out of a space or a room. So that's no surprise. But now I can have a two-story building. If it's B, F, M, or S occupancies with only one exit from the second story and the first story. I've got one exit for the whole building. If maximum occupant load per story, 29. Common path of egress travel, maximum 75. So that means from the second floor, I have to travel out of my office, it's a B occupancy, out of my office, into the corridor, down the corridor, to the stairs, down the stairs, across the first floor to the exit door, the exterior exit door. That's my exit. Common fact, no more than 75 feet. So these are not big buildings. But this is based on the story, the occupancy classification, the number of occupants per story, and my travel distance. So we're adding additional requirements in there. And there is a completely separate table that deals with group R2 occupancies. This handles everything else, R2 occupancies. So where do I put those exits? How do I arrange the egress? The code doesn't tell you exactly where they have to go, but it does have some parameters that they have to comply with. As soon as I have two exits required, I have to separate them so that they are actually two separate exits. To determine if they're adequately separated, I'll look at the maximum overall diagonal of the room or building or floor, but the maximum overall diagonal, and my exits have to be at least 1/2 that distance apart. Have to be at least 1/2 that distance apart. I've got a 100-foot diagonal. My doors have to be 50 feet apart or more. Exception to that, if the building's sprinklered, I can reduce it to 1/3. So now 100-foot diagonal, I'm down to 33 feet apart. And I can measure to any point in the doorway. I measured between the doors here. I'm going to measure to the other end of the doors now. That could be my 33 feet. But that means that complies with I have two separate exits. Each one of those is considered a separate exit. They could be on the same wall of the building as long as they're far enough apart. When we're looking at these measurements, all this measurement is done in plan view. The maximum diagonal, how far apart are the doors? Doesn't matter if the measurement is inside or outside the building. It's how far apart are they in a direct line measurement. My measurement for the diagonal went across the exterior of the building. That's okay. How far apart are the doors? And we talked about looking at each room, each floor, each building. So room A, that needs two, and this only applies again when I have two exits required. If my room only requires one exit and I add an additional exit door, it does not have to comply with this separation requirement. So I've got room A, I look at room A, complies. I look at room B, complies. Now I have to look at the floor or the building, taking the maximum overall of all areas served as my exits. I just have to have two. I've got two. I could have measured the half the diagonal to this one here. I just have to have two. Any two have to be that far apart. One exception to measuring in a straight line applies to a building that has a fire resistance rated corridor. If I have that fire resistance rated corridor, I still measure the overall diagonal, but now I measure the distance in the corridor. In the corridor. What's the separation of those exits in the corridor? When I need 3 exits, I've got an occupant load of 600. I need a third exit. I've got 3 here. How do we evaluate that? Well, we still look at half or a third if it's sprinklered. The maximum diagonal, I've got 2 exits that are that far apart. Okay, now I need a third exit. Where do I do that? There is no requirement for 1/2, 1/3, 1/4 diagonal apart. There's no requirement like that. What the code says is the additional exit or exits, if I need 4, have to be a reasonable distance apart. In other words, they've got to convince you a reasonable distance apart. So if one is blocked, the others, all of the others, are available. We're back to the same concept we had when we're looking at 2 exits. One's blocked, do I still have 50%? One's blocked, do I still have the others in this case? So that's going to be up to you. Certainly if it was half or a third of the diagonal apart, I would say, well, that qualifies because we allow it when there's only 2 exits. Could it be a fourth of the diagonal apart? Maybe. Could it be less than that? A fifth of the diagonal apart? Maybe. It's going to depend on the building or room layout. What works for that building? Are you convinced if I put the other exit right here, other exit, my third exit is here instead of here, would you believe that if that door is blocked, this one is available? That's what this is all about. How far apart is that? And it's going to be different for every building. When I'm traveling in my egress path, there is an allowance that I can travel through an adjacent room. I go into it. I don't have to go into a corridor. I don't have to go directly outside. I'm going to go into another room. It's allowed if the room I'm going into is accessory or used by or part of. There's some limitations on that. It can't not be an H occupancy unless I start in an H occupancy. I start here, this is H3, and then this is H3. That's okay because the hazard is the same. But I've got an office and an H3. I can't go through the H3. The H3 is the higher hazard than this. Even if this room is considered accessory, there's no occupancy separation. It's accessory. I still have to have another exit here. Now I could have an exit door here. That's my required exit. I have a door here to go into the H3. That's okay. But I still have my required exit that complies. So there are limitations to this. Can't go through a storeroom, closet, spaces for similar use. Cannot go through a kitchen of my restaurant. Can't go through the kitchen. Can go adjacent to the kitchen and separated by a wall, but it can't travel through the kitchen unless I'm in a dwelling unit or a sleeping area. So in my R occupancies, my hotel with the little kitchenette, my exit, hey, look at those things. They all go through the kitchen and the exit path. So it's allowed in those situations. The only thing that becomes the limit, how many rooms can I go through? As long as they are all accessory, not storage rooms, not closets, not kitchen. The only limitation is my common path of egress travel, because I'm going to measure my common path of egress travel from the furthest point, here, all the way out to the point where I have a choice of 2 directions to go. Now, I said that you can't go through a storage room. Like every good code provision, there's an exception for group M. for group M. This only applies to group M. So it says if I can have one of my exits. I shouldn't say that. I can have up to 50% of my exits. So in my group M, I'm required to have 2 exits. I've got one. There's my second. It can go through here as long as this door does not require any special knowledge. It's not locked. My exit path is completely available. This door is not locked. And my exit path is separated from the storage area by a full or partial height wall or other approved type of construction. I'm not creating a fire rated separation. In fact, the employees are going to use the same door to access the storeroom, to restock the shelves. They're going to be using that same door. So this is not even a continuous door, doesn't have to have a door, doesn't have to have a fire rated door. It's just an opening in that wall. But this wall is just intended to guide me. The wall, partial height, doesn't even have to go to the ceiling. The concept is that is going to be a physical barrier to separate the storage room from the exit path so that my storage stays on that side and my exit path is clear. Says other construction. I've seen this done with a chain link fence. It serves a purpose. Storage on one side, exit path on the other. It's allowed. I've got a intervening room here. I've got an office, secretary, another office. So when we're looking at this, we got to look at, is that a problem? Is it okay? Well, doesn't look bad. But we have to look at the specifics. Look at the occupant load. For my occupancy, we go back to our table, 1004.5, and based on the square footage, I've got a total occupant load in this space of 12. Total occupant load of 12. Based on 12, I need one exit. But I also have to look at the common path of egress travel. So when I look at that, there's my table. Oh, I've got 109 feet. I go back and look at table 1006.2.1, and it says if it's a sprinklered group B occupancy, I have 100 feet. Well, 109, that's just plus or minus 10%. Isn't that okay? No, it's 100 feet. And if I exceeded 100 feet, so the designer has options. I have 2 exits, or I can move the exit. I relocate this exit from here to here, and I'm going to measure again. Oh, 97. That solved the problem. Other option. I add a second exit, or I add a required exit out of the office. It only requires one door. It can swing in. Now, this is my required exit. This is just an additional exit. So then when I'm looking at my common path of egress travel, I measure from here to here. I've complied. So there's several different ways that the issue can be solved, up to the designer. When I'm measuring travel distance, I told you we talk about how do we measure. It's from the furthest point in each room to the nearest exit, not all exits. I've got 2 required exits for these. The room, I evaluate the room, 1 exit required. I evaluate the occupant load in the space, 2 exits required. I've got them. So now, but I'm measuring my travel distance. I measure 2, 1 exit. And wait, that exit's blocked. Yeah, I've got another one. It's a little further to travel, but I have another one. So I get to go to the other exit. And we talked about the way that I was measuring, 90-degree turns. 90-degree turns will allow you, because when you look at this on a set of plans, it's probably just an empty room. You see 4 walls. That's my classroom. This will allow you to maneuver around those objects. What the code says, it says you can measure along a natural and unobstructed path. Convince me that that's the path that they're going to take. Well, we've designed this. That's the only place we can put these desks because that's where all of our connections are. They're attached to the wall. They're built in place. They're okay. I'll buy it then. But you've got to convince me that that is in fact the natural path. That it's this way at certificate of occupancy, and it's this way next year because I've changed my exit path. I cannot go from here to here. Exit access travel distance. We're going to measure the distance, and it's measured along the path, and it includes stairways, ramps. When I get to the stairs, I'm measuring just a tangent along the nosing of the stair, the treads across the nosing of the stairs, like laying a 2x4 on top of the stairs. How long is that 2x4? The key is we have to measure it. We have to measure it. It's part of our travel distance. So from this mezzanine, we evaluate the occupant load. Good. Now we look at the travel distance. What's my travel distance to the nearest exit? Travel distance measurement. We looked at this before when we were looking at common path of egress travel. So we're going to start here. It's not always measure from the furthest room. Measure from every room. Which one has the worst case travel distance? This one. I'm coming here and here. That is my common path of egress travel, which we've measured. Okay, that complies. I continue to measure, and then I add them together. Travel distance of 145 feet. Oh, good. I had 200 feet to work with. It complies. But it's not always the furthest room that has the longest travel distance. The way this is configured, if this door was down here and entered the corridor, this probably would be the furthest point. But we have to look at each room, each point, each space in the floor. What's my travel distance to the closest exit? I have another exit this way because I had a choice of 2 directions right here. Closest exit is all I have to comply with. Well, how far can I go? It depends. What's the occupancy of the building? Is the building sprinklered, which gives me more time to exit? Let's pick an A occupancy now. Not sprinklered, 200 feet to the exit or to an exit. If it's sprinklered, 250 feet. So we go to this table to determine what's the maximum travel distance to an exit. And an exit is one of those 7 items. Even if this is a fire-rated corridor, 1-hour corridor, this would be the proper measurement to an exit. When I have more than one exit, I have to address dead-end corridors. Ideally, we would never have dead-end corridors, but we do. We do, and it's allowed. The general requirement is the dead-end corridors no more than 20 feet in length. It can be increased to 50 feet in an I3 or in group B, E, F, M, R, and U, S and U occupancies if the building's sprinkled with NFPA 13. Note that this allowance says NFPA 13. Even though it may be a hotel, apartment building, assisted living space, I have to use NFPA 13, even though 13R may be appropriate. I don't get the credit for the 13R system with regard to this. So what is my dead end corridor really? Where do I measure the 20 feet or the 50 feet? Because the whole concept is essentially look at it this way. How far do I have to backtrack? How far do I have to backtrack? I made the wrong turn. How far do I have to backtrack? That's my measurement. The distance from the end of the corridor to the point where I should have turned. 20 feet or 50 feet. But there are times when I don't even have to worry about it. And that's essentially when my corridor is treated more like a space or a room than a part of the corridor. When the length of the corridor does not exceed 2.5 times the width of the corridor. And otherwise, it's not a long, narrow path. It's a wide, shorter area. So I've got 18 feet by 38 feet. My 18 feet times 2.5, 45 feet. The length does not exceed 45. This, even though it is dead end, it's not treated as a dead end corridor. The building was allowed, it could only have a 20-foot dead end corridor. It's a wider space. It's not considered a dead end corridor. That would work. So I don't have limitations. And let me go up. Let me go back to this one is the one I wanted. Even if this is 75 feet, as long as it's wide enough, it's not considered dead end. Even though I've exceeded the maximum of 50 feet, it's not considered a dead end. It's considered more of a space. I still have issues with the longer this gets, how far do I have to go to have in many cases, 75 feet may be the maximum because this is my common path of egress travel to here. My common path of egress travel for this room and this room from here to here to here to here may be a limitation. But the key is we don't measure from the last door in the corridor to the end of the corridor. That's not the measurement we're looking at. We're looking at occupants traveling in this corridor. They get misdirected. How far do they have to backtrack before they get back on the path to the exit? Okay, I've got my exit doors. I've determined what we need. What kind of door can I put in? What kind of hardware goes on the door? I've got a requirement that says the doors have to be readily distinguishable. Placement of the exit sign is, in my opinion, not make it readily distinguishable. This would be a problem. It doesn't, you can almost miss the fact that the door is there. So they need to be readily identifiable, readily distinguishable. The code says, we talked about, in fact, adding extra doors. This is my required exit. This is an exit door, an extra door that works as an exit. Code says, if I have additional doors, they have to meet the egress requirements in section 1010. So what does 1010 say? It says they have to, if the door has to swing out, this one has to swing out. Whatever hardware is required, same hardware. If it's panic hardware, has to have panic hardware. If it's a lever action, could be lever action. What's the minimum size of the door? How hard is it to open the door? What's the force? Do I need a landing? Everything that applies to this exit door applies to this one if it could be used as an exit door. The one thing that is not in section 1010 is the exit sign. Here's my required exit. This is just another door that gets me outside. So they don't have to have an exit sign there. But when I'm evaluating my exit access travel distance, I can't measure to this door. That's not my designated exit. This one is. I measured to this door. Well, wait, we don't comply if everyone has to go to that door. Okay, so I need this. I need this door. Now it's a required exit. I need the exit sign. Door swing. Egress doors shall be pivoted or side hinged swinging doors. A pivoted door swings on an axis that is not hinged at the end. It swings on an axis, and as that door opens, that axis moves back towards the door frame. That is a pivoted door. Often done when I have doors that are wider than 36 inches because there's less weight to move. It's balanced a little bit. It's balanced. When we're looking at the door swing and the door width, we look at the side hinge doors also. Here's my clear width of 32 inches from the door face to the stop. That's my 32-inch requirement. The requirement is for an exit door has to be minimum 32 inches clear width, not the door itself. Typically, I'm going to do this with a 36-inch wide door, and I end up with a 32-inch or 32 and a half or 33-inch clear width. That's why when we're looking at the amount of inches in the that each exit provided, I had 32 inches for a single door, even though it's a 36-inch door. 32 inches is my clear width, and we always measure that at a 90-degree angle. Even though the door may swing completely open, we measure it at a 90-degree angle to the door face, not the hardware, the door face to the stop on the other side. There are some exceptions to when I have to have the 32 inches. We need to take a look at those, like in a dwelling or a closet or certain spaces, but there are some exceptions that apply. But other than that, 32 inches is the exit width we're looking at. When do the doors need to swing in the direction of egress travel? When the occupant load is 50 or more, regardless of occupancy classification, 50 or more. If it's a group H, all of the exit doors swing in the direction of exit travel. If it's an exterior exit door, it's the door at the exterior wall in an I2, all of those doors swing in the direction of exit travel, regardless of occupant load. Doors in group L, my laboratory suites, group L. If the room I'm leaving has hazardous materials in it, all exit doors, regardless of occupant load. Electrical rooms. If the electrical room is wider than 6 feet and it has more than 800 amps worth of equipment in the room, the exit doors have to swing in the direction of exit travel. This is this is a different requirement than panic hardware. This requirement have to swing in direction of egress travel. It could, in some cases, have lever action hardware. Obstructions on the door. No obstructions in the bottom 34 inches. In fact, 34 inches is the bottom height of my hardware mounting. No projections allowed above from 34 inches to up. No projections wider than 4 inches into my exit width. Let's go back to this one. My panic hardware, my door hardware, above the 34 inches, 4-inch projection into that exit width is allowed. Door closers can be have to be at least 78 inches above the floor. That gives my door opening. My hardware, my latch, lock, lever, whatever the hardware is, 34 to 48 inches. The hardware that cannot require tight grasping, tight pinching, twisting of the wrist. So the old doorknob, no. The thumb turn deadbolt, no. Lever action or panic hardware. Essentially, the requirement for door hardware for egress is I need to be able to open it with my elbow. Panic hardware, lever action. If I can do that, I have a device that complies. That's one of the ADA requirements. There is an allowance to put the lock higher when I have doors that access a pool, spa, hot tub. This is my child-proofing solution. I can put the lock higher or the latch higher, up to 54 inches max. I'm sure you've been into a facility that doesn't have panic hardware or a lever action on the front door. Instead, it's got a deadbolt. That's allowed in certain situations. It's a group A occupancy. The occupant load's no more than 300. It's a B, F, M, or S occupancy, or it's a place of worship, regardless of occupant load. It's allowed on the main entrance. The concept being, I'm going to unlock that with my key and let everyone in. It's already unlocked, so when they want to leave, they can get out. They can get out. It's not locked. At the end of the day, I lock it up with my key and I leave. So this is allowed. All of the other doors would meet the requirement for my lever action or panic hardware as required. To allow this, and this is a deadbolt, key operated deadbolt, no thumb turn, key operated deadbolt. Key from both sides or key only from the outside. That's okay. That's okay. Or key only from the inside, but no thumb turn. I have to have a sign placed either above or adjacent. Door to remain unlocked when the space is occupied. The door has to be open. The sign has to be at least 1 inch high letters. The ability to do this is typically an allowance in the code that says, you know what, you're in at A occupancy and you need panic hardware. This is allowance say, you don't need the panic hardware on this front door. You're going to put this deadbolt in, key operated deadbolt. First time we come through here and you're not unlocking it like you're supposed to, we're going to revoke your ability to use that allowance. And now we go back to panic hardware. This door, this is the active leaf. This is the inactive leaf. The hardware is on the active leaf. Okay, knowing that, surface mounted bolts and flush bolts are prohibited. This is an edge mounted flush bolt on the edge of the door where it would be located here and here. So to release it, I would unlock this door and then manually release those top and bottom that lock into the frame and the foundation. Wait, it says they're prohibited on an exit door, but there are some exceptions on my dwelling. It's a storage room where I only need one exit or one door to meet my exit requirement. It's a B, F, or S occupancy with an occupant load of less than 50. It's a B, F, or S occupancy that's sprinkled with NFPA 13. The inactive leaf repair doors is for patient care rooms, and I don't need it for exit width. All of these, anytime that I do this, I don't need that second door for exit width requirements. Okay, so where does it say here, I can't do it in my group M? Or I can do it in my group M. Well, it's group less than 50, no. Sprinkler, no. Basically, it says it's not allowed. How do I solve that? I've got a pair of doors. How do I do that? This lock is a different lock. When it locks into the other door, it also locks top and bottom in that other door, or maybe in the same door. So the one key unlocks both doors. That's how this should be done. When do I need panic hardware? And we have two types of hardware in the code. We have panic hardware and fire exit hardware. The difference, and there is a difference, the difference is fire exit hardware is panic hardware on a fire rated door. It goes through a different set of testing criteria, so we know that it's going to hold that door closed during the fire testing process. Panic hardware is not required to do that. Not required to do that. Fire exit hardware is. So anytime I put panic hardware on a door that is fire rated, it has to be fire exit hardware. How do I know the difference? Because they look nearly identical. I have to look at the label. It will say right on the label, fire exit hardware or panic hardware. Is it a fire rated door? Yes, then I need fire exit hardware. I can use fire exit hardware on a door that's not fire rated. I cannot do panic hardware on a door that is fire rated. So when do I need panic hardware? All group H occupancies, all group H. Group A with an occupant load of 50 or more. Except those allowances where we said on the main entrance, I can have a key operated deadbolt. Group E, I2, 2.1 with an occupant load of 50 or more. Group L, rooms with hazmat. All of those doors had to swing the direction of egress, and they have to have panic hardware. And then my electrical rooms. Those electrical rooms that require the doors to swing in the direction of egress travel have to have panic hardware. That's the only place panic hardware is required. Well, where does it say I have to do it in an M occupancy? It doesn't. It's not required. It's done often, I know, but it's not required. The panic hardware is a single action. That's what's required on an exit door. Single action, panic hardware. Single action, lever. On all occupancies other than these, the lever action is acceptable. Let's go back. There are times I will find panic hardware in buildings that have delayed egress, where I have electromagnetically controlled exit doors. As part of those components in that special hardware provisions, I may have panic hardware also. My corridors. I have my corridor width. We looked at our inches and exit width. We have the requirement based on the exit width, based on how many people, is the building sprinkled? Does it have emergency voice alarm communication system? What's my width? And I have to meet this table. This is, when we did that one of the first examples, we had a corridor. I said, wait, minimum width is 44 inches. Here's our table, table 1020.2, that says minimum width is 44 inches. The width of the corridor or the width of the exit passageway has to comply with this table and with this criteria. If this requires a wider width, you've met this. If this is 40 inches and I need 44, I do 44 inches. So what does this table say? Basically says the two most commonly used ones, serving an occupant load less than 50, 36 inches. Everything not listed below, 44 inches. So there are some specific examples in here. Group E, occupant load of 100 or more, 6 feet. Ambulatory care facility, 6 feet. I2, 8 feet. I2 and I3 with non-ambulatory persons, 8 feet. 8 feet. So everything else that's not listed here, 44 inches. Can I have obstructions in the corridor? I'm going to have obstructions in the corridor. It says that the door, when it swings in any position, cannot obstruct more than 50% of the required corridor width. Not more than 50% of the corridor width, but what's the required egress width? I needed 44 inches. The most I can obstruct then, I'm going to obstruct this side, is 22. I have to have at least 22 remaining. In other than group I2, when the door is fully open, and any door that opens into a corridor has to swing 180 degrees. It has to swing back against the wall. 7 inches maximum from the door face, not the hardware, the door face to the wall, maximum obstruction width of 7 inches. When does my corridor need to be rated? We have another table. Based on the occupancy, the occupant load, and then is the building sprinklered? Is the building sprinklered? So when I look at this, I say, okay, I've got an A occupancy. Occupant load's greater than 30 because it's an A, and my occupant load, I've got 80 occupants. Not sprinklered, I need 1 hour construction for my corridor. It is sprinklered, no rated corridor. For my B, same thing, F, M, S. I don't know if we even do corridors in a U occupancy, but many times when I put the sprinklers in, I eliminate the need for a rated corridor. This says buildings equipped with NFPA 13 or 13R. Where allowed. What where allowed means I can't use a 13R sprinkler system in my M occupancy, but I can use it in my R2 or my R1. So those are the allowances, and this is the common one we run into. 1 hour without sprinklers, no rating if the building is sprinkled. So what do I do with that corridor to get a rated corridor? My walls have to have a 1 hour rating. All my doors have to have a 20-minute fire protection rating and door closers and a gasket on 3 sides of that door frame, not the floor. All my glazing is either 45-minute fire protection rated or 1 hour fire resistance rated. Fire protection rated means it's an opening protective, in which case it's limited in size. How much area is how large is it? If it's 1 hour fire resistance rated, it is tested to be equivalent to the 1 hour wall, unlimited in size. In addition to that, all of my ductwork penetrating that corridor, penetrating this 1 hour fire resistance, has to have a damper in it, fire smoke damper. If it's in the ceiling, I've got a corridor damper or a ceiling damper. That's appropriate. There's a lot of requirements that when you say, oh, we don't need 1 hour corridor, there's a lot of things that fall away when the 1 hour corridor is gone. My exit passageway, which looks like a corridor, It's slightly different. Let's go back here. I come out of this room. I've got an exit at both ends of this corridor. I get into an exit passageway. I get in. There is only one exit out of the exit passageway. It's one-way travel. And it is constructed of either 1 hour or 2 hour construction. If I'm connecting this end, and there's a stairway that comes down from the 7th floor, and it's in a 2 hour shaft, and this is getting you from the stairway to the exterior wall of the building, this passageway is then a 2 hour construction also. With my 1 hour construction, I need a 1 hour wall or 1 hour door. My corridor, 20 minutes. 2 hour construction, hour and a half rated door. And one of the key things, no openings from other spaces. So the only doors entering an exit passageway or doors into an exit passageway are doors that are exits. I can't have the bathroom, the mechanical room, I can't have the drinking fountain because nothing comes in this exit passageway that doesn't have to be there for it to function as an exit passageway. So that limits me to things like sprinkler piping, standpipe piping, electrical for lighting, HVAC. Nothing penetrates that protected pathway unless it has to be in there. Terminates at an exit. Other option, one of our other exits is a horizontal exit. Horizontal exit is designed so I pass from one area of the building to another. It cannot be the only exit. It's limited to a maximum of 50% of the exits required. Unless it's an I2, then it can be 2/3. Or if it's an I3, it can be all the exits. I never let them leave the building in an I3. To construct this, I have a 2 hour wall, 2 hour fire barrier, hour and a half openings, all doors open and close automatically or self-closing. This is the type of door arrangement you will see in a horizontal exit because I have occupants in area B exiting into area A, occupants in area A exiting into area B. How do we figure that? I've got occupant load of 160 in area A, 2 exits required. There's 1, there's 2. These occupants have entered an area of safe refuge, essentially. But a protected area passed through a 2 hour wall, they now have more time to exit the building. Current code says, wait a minute, if whatever the occupant load here is, it's based on, we're going to assume that the maximum occupant load that this door can handle travels this way. So that is 160 occupants. So now I've got 160 occupants. Wait, that was everybody. Yeah, that was everybody. I still have to have a second exit. But for evaluating the horizontal exit, I'm going to assume they all go this way. This one was blocked. They all go this way. Now, when they're in there, I take the occupant load in area B, add the occupant load from area A, 680. I have to have 3 square feet per person for standing area, basically staging area as they're waiting to exit the building. They're all going to leave the building. It's just going to take them longer now because I've got this additional 160 people in the building. So area B, I looked at area A, now we're going to go the other direction. Area B requires 3 exits. 1, 2, 3. 160, 160, 300. Same thing. I get 160 over here. Now I establish my square footage, and this could be area for, it's in the corridor. Do I have enough area to put all these people is all we're looking at. I've never seen, excuse me, this calculation be one that fails in these designs. But I get over on this side, and when we say, okay, now we got 320 over here, we don't go back and say, okay, with 320, we need to reevaluate the exits. No, whatever's provided for this side, it'll just take them longer to use that exit. But I can use my exit and horizontal exit from both sides. Well, why would we do that? Why would they be doing that in a fire? They aren't. The fire is going to be either here or here. So during an incident, they're using one direction of this horizontal exit, not both. The horizontal exit in a multi-story building, I have an option. Either my 2-hour wall is from foundation to ceiling or to the roof, or if my floor ceiling assembly is also 2-hour rated, it could be just on that floor. It could be just on that floor. The stairways. Stairways defined, and the term flight is defined. I have a set of stairs when there's just one riser or more. A single riser could be a stair. So we regulate the height of that riser, the depth of the tread. But the term flight is important because a flight is from landing to landing. This is a flight of stairs. This is a flight of stairs. This stairway here is 2 flights of stairs. They're going in the same direction, but it's 2 flights of stairs. We'll see in a minute why this is critical. I didn't mention this. All stairways, all stairs in a building are regulated, whether it is an access or an egress stair or not. All stairways are regulated. It's the stairway for the mechanical loft. It's regulated. Stairway from I get outside the building, the stairway to the public way, it's regulated. We're controlling the amount of falls, trips, injuries that occur on the stairs. So my stairway width, I'm looking at my 0.3 inches per person as my stairway width, and I have some minimums again. 36 inches or 44 inches if it's more than 50 or more, and we're measuring tread, edge of tread to edge of tread, edge of tread to edge of tread. Even though I've got a handrail, and I'm going to require a handrail on both sides, that could be 4.5 inches into that stairway width. That's allowed. That's allowed. The only time I measure between the handrails is when I'm looking at accessible means of egress in a non-sprinklered building. Then I need 48 inches between handrails. It exceeds both of these, but I need 48 inches between handrails. Or I put sprinklers in the building. Either way. Maximum rise, 7 inches maximum, minimum 4 inches. The run, the tread, minimum 11 inches. That's where we get the 7-11. This is commercial application. In residential application, the numbers are different. Commercial application, 7 and 11. When we look at the variation between tread, or I said we talked about what is a flight of stairs. Within each flight of stairs, from landing to landing, there can be a maximum difference of 3/8 of an inch on the tread run or the tread riser. Maximum 3/8 of an inch difference in that flight. This is critical because if you've ever gone down a set of stairs at any kind of speed and you, whoa, that one was different. You notice the difference as you get a little cadence going. But it's that different one that causes people to tumble, trip, fall. We're trying to control that different one and eliminate that different one. Stairway landing. Can I have obstructions on the stairway landing? I've got doors that swing into the landing. That's how I get into the stairs. Like our corridor, the door in any position cannot obstruct more than 1/2 of the required width. The door at fully open position can obstruct no more than 7 inches. Notice I'm not measuring to the hardware. I'm measuring to the door face, because that requirement applies to the door itself. The stairway construction. Can I have storage underneath my stairs? Can I put storage underneath the stairs? You can if you separate that storage with 1 hour construction. If I'm in a stair enclosure, my interior exit stairway, the answer is no, you cannot. So this would be applicable to an exit access stair. Can I store beneath that? Yes, you can, as long as you separate it with 1 hour construction. So what type of stairs do we have that are allowed as an egress path? Like I just said, that the code regulates all stairs. Here's a curved stair. Definition of a curved stair is the radius of this curve right here is twice the radius of the required width of the stair. So it's a slow turn. That's a curved stair. This can be used as part of a means of egress. Spiral stair. My interior curve of the stairs is not twice the radius or twice the stair tread width. It's a spiral stair. Allowed for egress in dwelling units, not commercial. It can be used in commercial if I'm going to access a machinery space or an equipment room. Alternating tread device. This device is it's a stair, but it has only half a tread at each level. So it's right foot, left foot, right foot, left foot. And looking at this from the side, it's very steep. It's like a ladder. It's allowed in certain areas, not the main path of egress. Ship ladder is allowed in certain specific uses: equipment rooms, unoccupied roofs, lifeguard towers. But it's a steep ladder. A regular ladder attached to the wall. Permanent ladder towers, unoccupied roofs, maintenance, equipment loft. It's allowed. All of those are regulated and allowed by the code. Code also says if my building is 4 more stories in height, I have to have at least one stairway that extends to the roof level if the roof has a slope of no more than 4 and 12. It could be my stairs I continue to the roof, or it could be one of these 3 types of stairway designs that gets that last level to the roof. Another exception says, but if the elevator equipment's on the roof, it has to be the standard set of stairs. When do I need handrails? Handrail on one side only in a dwelling unit, or spiral stairs, which are allowed in my dwelling unit, or R2, R3. No more than 3 risers. A handrail on both sides. Everything else, when there's more than 2 risers or more, I need a handrail. Part of the reason for the handrail is, one, with only 2 stairs, it's an identifier that there's a change in elevation. So it's trying to eliminate or give a visual cue, beware, instead of tripping on the stairs. When do I need an intermediate handrail? The code says when we're looking at our means of egress capacity, how many inches did you provide? And we need 0.3 per person in our stairs. Well, when we're looking at this, you only measure the stair tread within 30 inches of a handrail. I only get to count 30 inches of that tread if it's within 30 inches of a handrail. So as I'm going down the stairs and I hit that one that's not the same as the others and I trip, I've got a handrail close by that I can grab and steady my fall. On wider stairs, hey, my stairs are 10 feet wide. Yeah, but you only get to count 60 inches of it. Option, put an intermediate handrail in. It is not, we do not consider it an obstruction. We don't worry about that. I could have 4.5 inches obstruction over here. We don't worry about this. But that gets me the allowance to utilize the full width of my stairs. Chapter 4 of the building code talks about scissor stairs in a high rise, where I have 2 actual sets of stairs in the same stair enclosure. The people traveling down this side never mix with the people going down this side. It's 2 completely separate set of stairs that just wrap around each other all the way to the bottom. It's considered one exit. That is one exit. I entered from 2 sides, one exit, because we're all in the same exit. That is not 2 exits out of a floor. Stairway enclosure. My interior exit stairway required to be in a fire resistance rated enclosure, not my exit access stairway. It can be without an enclosure. So my stair, 4 stories or more, 2-hour construction. Less than that, 1-hour construction. Or at least the same fire resistance rating as the horizontal assembly that it penetrates. 1.5-hour door for my 2-hour stair shaft, 1-hour door for my 1-hour stair shaft. One of the requirements is no, again, like our exit passageway, nothing enters that stair enclosure that's not required for the operation of the stair enclosure. Exit access stairs, no stair enclosure, no stair enclosure at all. It's open. It's allowed. When we're looking at travel distance, we're measuring from wherever the location is on the 2nd floor to the stairs, down the stairs, to the exit on the 1st floor. But there are certain occupancies, other than I2 and R2.1, that I can have an opening between connecting 2 floors. No requirement to enclose that. But now I'm going to use that same exit. I'm going to use that same open stairway. I'm going to connect multiple floors. I can do that, but in this case, it is not considered an exit. It's not considered an exit stairway because it's not in a fire resistance rated enclosure. But I put my stairs in, and then I construct a soffit around the perimeter and add sprinklers outside of that to create, they're going to spray off the soffit and create a water curtain around that opening. It's allowed to have this opening. There is no wall on each of the floors. I can do this in a building that's B or M occupancy. It could be all my floors. I could connect every floor in a B or M occupancy, protected in this fashion, but this is not my exit. I still have 2 exit stairs from the 5th floor in addition to this. That's my required exit. This is often referred to as a convenience stair. Other than B or M occupancy, maximum 4 floors. R occupancy, maximum 4 floors. So there are limitations in other occupancies. Inside my stair goes from the 5th floor to the 1st floor and then down 2 levels to the 2 lower basements. When I get to the level of exit discharge, which is where we want people to leave, I have to have a couple things. I have to have an exit sign. That is the only exit sign inside the stairs. All the other exit signs are outside the door into the stairs. Outside the door into the stairs. So the only exit sign inside the stair is at the level of exit discharge, and there's a barrier to keep me from just winding down to the bottom of the stairs. When I get to that barrier, I hit it, I have to open it up. It's in the direction of travel from the lower floors coming up to the level of exit discharge. So I'm going to have to stop, open it up, and then continue down. The intent is just to get me to stop and realize something's different here, hopefully see the exit sign, and exit the stairway. When I have stairs that connect more than 4 floors, I have to have signs, identify the stair, identify the, do I have roof access? What floor am I on? It's going to read that in Braille and raised, and the rest of this is raised characters. What floors does this stairway serve? Where's the level of exit discharge? That's my required sign when I have 4 stories or more in a building. 4 stories or more in a building. When do I need exit signs? Basically, code says when you have an exit door, every exit door needs an exit sign. But then it says, well, wait a minute. If you only need one exit, you don't need the exit sign. Or if you have a main exit that's clearly identifiable, you don't need an exit sign over that door. So there are some exceptions there. So here's my layout. One of the other requirements is I need to be able to see an exit sign within the maximum viewing distance of the sign. 100 feet is the maximum. There are some exit signs that say on them because an exit sign is listed. The maximum viewing distance is 75 feet, or the maximum viewing distance is 50 feet. That's going to require I add more signs. But I've got one at each end of the corridor. I've got one out of this room requires more than one exit. I've got them at the exit doors. I step into the corridor. I can see the exit. This room requires 2 exits, one at each exit. I step in here or out in here. I can see the exit. These rooms do not require 2 exits. No exit sign required. Here then is a question. Main entrance. Do I need an exit sign there? If it's clearly identifiable, and this is the code official call, clearly identifiable, you don't need to put it there. Exit signs. You're out doing your inspection. I step out into the corridor, and I stepped out in the corridor. I said, where's my exit sign? Oh, wait. Well, maybe it's the other way. The problem is, and this building had the same problem. When they added soffits in for the sprinklers, they obstructed the exit sign. This was a remodel. This is a remodel where they added sprinklers into this building, and now they've obstructed the exit signs. They need to be relocated so they are usable, visible, and obvious. Also, at exit stairs and exit doors, we need to have Braille and raised character or tactile signs. Certain requirements, certain locations identified. My stairway door into the stairway, my exit door, horizontal exit. All of these exit requirements are required to have a tactile and braille sign. The exit sign itself has to be illuminated during all times of when the building's open, either internally, externally, or self-luminous. There is no light on this. It glows. It's radioactive. It has a radioactive component in it. Has to be self-luminous. The requirement is, if I have a required exit sign, I have to have lighting for the sign. And if I have a required exit sign, I have to have secondary power for the lighting for the sign. So that means either a generator, or I've got a exit sign with a battery backup that's built into it, or I've got a self-luminous type sign. This one here, hopefully you're not seeing this one in new construction, but I could do this with emergency generator supplying that lighting. But in addition to lighting for the exit sign, I need to light the egress path to the exit. So I have egress illumination in my exit access to the exit. This is in addition to illumination of the exit sign. It's not replacing it. It is in addition to. So at the floor level, when all the power goes out and these come on, I have at least 1 foot candle at the floor level. Where do I have to provide the egress illumination? Rooms that have 2 means of egress, corridors with 2 means of egress, exit access stairways, and exit stairways. So either of my stairways, my exit access stair and my exit stair, require power for the illumination. Vestibules, exterior landing. The exterior landing at the exit discharge. As I step out of that exterior exit door, the landing is illuminated. From there to the public way, I'm on my own. But at least the landing is illuminated so I can get rid of the building. Additionally, things that are not really exits that you'll find in Chapter 10 for emergency illumination. Equipment rooms, fire command center, fire pump room, generator room, and public restrooms greater than 300 square feet. They all require secondary power for egress illumination. Exit path markings in a building. Egress pathway in my stairway, in my high rise for A, B, E, M, and R1 occupancies only. Mark the stair tread. So I've got in my stairway, I've got normal lighting, I've got my egress illumination, and then when that fails, I have luminous markings that are going to basically they absorb the light and then they glow. That they will still provide the ability to exit the facility. Exit path marking, not in the stairway now. This requirement is in the stairway. Now I'm in the corridor leading to the stairway. It's required if I have an interior fire-rated corridor and it's non-sprinklered and it's a group A, R1, or R2. New construction, you're probably not finding it. However, there is a retroactive requirement that says I've got to comply. I've got to add this into my existing building if it's non-sprinklered and it's A1, A, R1, or R2. I have to do that. Okay, we've made it to the exit discharge. I'm now leaving the exit. I'm in the exit discharge. I've got to get to the public way. So I leave there. I've got to have a way to get there. Once I leave the building, I'm in a fenced area. I have an option. Either put a gate with the same hardware as was required in my exit in the building. So if my building required panic hardware, That gate requires panic hardware. But I've got to be able to get to the public way. I've got to be able to get to the public way. I do not, it says exit discharge provided with illumination. That does not mean secondary power for that illumination. But during normal operation, I leave Home Depot and I'm in the parking lot. I have lighting to the public way. Power goes out in the area. I don't have lighting to the public way. The only thing I do have would be a light at the exterior door to illuminate the landing. Emergency power is not required for the lighting all the way out to the public way. Option. I don't get to the public way because I'm in a fenced facility. So when I leave the building, I go to a safe dispersal area. 50 feet away, at least 5 feet per person. So whatever my occupant load is here, I've got to have a safe dispersal area identified with a sign that says this is my safe dispersal area, and I can get everyone 50 feet away. 50 feet in a group E applies to all buildings. I'm 50 feet away from every building. In all other occupancies, it's just 50 feet away from the building I left. So if I have multiple buildings here, I could have one safe dispersal area here. I've got another building here, and my other area is over here for safe dispersal. Because again, we're planning on one incident at a time. So it's in this building, we go here. It's in this building, we go here. But this is allowed for all occupancies, not just Group E. Okay, questions. If you have any questions, load them up in the chat box, and we'll see what we got. What are the exit access corridor? What are the details about fire? Okay, an exit access corridor. Says, what are the details, fire dampers, etc., fire rated, non-fire rated corridor for exit access. If it's not a fire rated corridor, there is no requirement for fire dampers, for door closers, for rated construction, for limitations on glazing as far as size or fire rating. It may have to be safety glazing, but other than that, there's no rate. The only time I have to deal with that is when I have a fire rated corridor. It would still be called an exit access corridor, but my fire rated corridor, then I have to have everything is the 1 hour construction, 20-minute doors. Doors have automatic closer held open with a magnet or self closer. I open the door, I let it go, it closes and latches. Around that door on the sides and the top, I've got a gasket to stop the spread of smoke. We don't worry about the bottom of the door. If you have smoke coming out the bottom of the door, you need to be somewhere else. You shouldn't be seeing that. Firefighters will see that. Do circulation areas. Do circulation areas include, are they included in the occupant load analysis? I'm not sure what you mean by circulation area. However, let me answer it this way. When we look at occupant load, other than the gross and net issue, we anticipate all areas being occupied. For example, I've got an office building and a conference room. We anticipate that the office areas are occupied and the conference room is occupied, even though it may be some people out of the offices that are now in the conference room. We design it so they're both occupied at the same time. We anticipate the whole building is occupied, other than the net allowances for the floor area. For a B occupancy building, assumed travel distance is not an issue. What's the maximum number of stories for an exit access stair? Two answers to that. An exit access stair, which is the one that is not in a fire resistance rated enclosure, I can connect 2 floors in my B occupancy. However, if I provide a soffit and sprinklers around the perimeter on every floor, in my B occupancy, now my exit access stair is unlimited. It could serve all the floors in my B occupancy, but only if I provide that additional level of protection. For an exit stairway in a building over 3 stories, 2-hour separation for the stair and the building is required. What is the opening protection requirement for building opening within 10 feet of the exit stair? Okay, this is for an exterior stair, which unfortunately we didn't have time to cover, but the exterior stair, the stair outside the building, it does not have to be in a shaft or an enclosure. It could be open. It's limited in height to 6 stories maximum because I don't have to have that enclosure. But when I'm outside the building, I still separate this exterior stair from the building. But that wall, even up to 6 stories, is required to be 1 hour construction, not 2 hours. 1 hour construction on that exterior wall. Any part of that wall that's within 10 feet of the stairs. Within 10 feet of the stairs, 1 hour construction. Any openings in that wall, openings, windows, doors, have to have 45-minute rating. For an apartment building, one of the stair shafts designed to exit to the first floor lobby, then exit out through the door. Does the lobby have to be designed as a 2-hour exit passageway? Or is there an exception? Yes, there is an exception. The general requirement is we start with every interior exit stair has to end at the exterior. If it doesn't, 2 options. I provide my exit passageway to the exterior, or 50% of my exits could empty into the lobby, as long as the lobby is 1 hour construction, regardless of height, and the lobby is sprinklered. And when I leave that exit door, the door out of the stairway, when I step out of that door, I can see the exit. I have to be able to visually see it from that point. It can't be around the corner and down over here. I have to see it so I know my exit path. That is allowed. Any other questions? Okay, then Maria. Oh wait, one new question. Circulation area between fixed seats in a restaurant. Okay, question is, does a circulation area between fixed seats in a restaurant include an occupant load analysis? Okay, I'm going to go to my restaurant. We're going to pick a restaurant to make this real. We're going to pick one. I don't know if you're familiar with it. McDonald's. We're going to go to McDonald's. And in McDonald's, we have fixed seating and we have the order area. So in my fixed seating area, all of that area, I've got aisles in there serving the fixed seating. But in the fixed seating area, we count the seats. And we're done. The aisle space is my exit aisle, my access aisle. We don't do anything with that. However, now I've got my waiting area at the registers, at the cashiers. We're back to standing space. That's my standing space. And my table would give me standing space on for that area of 7 square feet per person. I can't get to it. Shouldn't have done that at all. But my standing space of 7 square feet per person. So I'd calculate the standing space and I'd add what I counted for my fixed seating. That would be my occupant load for that area. But then I also have an occupant load for the kitchen. What's my occupant load in the kitchen? So that would be how I would evaluate that. Floors with mixed occupancy groups. How do you measure maximum allowable dead end space? Okay. When I'm looking at dead end corridor, and I have a allowance for a different, this occupancy says, hey, for this occupancy, I get 50 feet dead end corridor. This occupancy says I get 20 feet dead end corridor. If they're both using the same corridor system, we use the most restrictive. If the exiting is separate, completely separate, all my required exits go one way for the R occupancy, go the other way for the A. I can look at them separately. But if they intermingle, I have to use the most restrictive. For floors with mixed use occupancies, how do you measure max allowed dead end corridor distance? Okay. I think I just answered that. Accessible means of egress. No, I did not cover accessible means of egress. There's no way to do that in 2 hours other than that lever. That lever is what we talked about. There's lots to cover. That's a whole separate issue on its own, accessible means of egress. But just in a quick little nutshell, if I have all my required exits have to be accessible. They have to be they have to meet the accessibility requirements. So if I have exit doors in my building, it has to meet the accessibility requirements. Don't disregard it. Don't disregard it. Does occupant load for large restrooms be part of an occupant load? Does the occupant load for large restrooms, is it included in part of the total occupant load? It depends how you're doing this. If the way I suggested, just take the whole floor area, take the whole area and divide it by the occupant load factor, yeah, I'm going to include it. If you get down to the gross versus net issue, in a gross area calculation, it's included. I would just use the same occupant load factor that I'm using for the rest of the floor. In my net floor area requirement, I exclude the restrooms. And I'm making the assumption that the people in the restroom are people that were in the other areas of the building. So the occupant load didn't change. They just have moved into another area of the building. Okay, I don't see any more questions. So, Maria.
Thank you, Mr. Kevin Scott, for a very informative webinar. I would also like to thank each and every one of our participants for joining us today. Thanks, everyone. Bye.